In this video, I will try to help you understand parallel and perpendicular lines. Now there are two pictures here that I want to start with, and that's just number one to address our parallel and perpendicular lines. For part A here, it says find the slope of lines A and B. And this is my line A here, and this is line B labeled there on your paper. Now the slope of the line is determined by your rise over run. So if you pick a starting point, and it doesn't matter exactly where you start, but pick a point that's clearly labeled on the line. And what we want to do is track our rise and our run to the next point. The rise and run to the next point. Now in this line I'm tracking, I see my rise is 1 and the run to the next point is 2. And you always want to track your run going to the right for your slope. Now in line B, notice how versus starting at +4, this line is starting down here at -3 on the y-axis. And if I track my rise over run to the next point, I'm noticing that the rise and the run is very similar to this line. In fact, the rise over the run is exactly the same. And parallel lines, you will note that parallel lines are sometimes denoted like this, with two lines that are kind of going in the same direction. Two lines are parallel if their slopes are exactly the same. Okay, so their lines need to be going in the same direction, which means same slope. Now in this picture over here, for graph B, find the slope of the lines C and D. Now in line C, I'm going to start at my y-intercept, and I'm going to see if I can find how far down to the right it is going, and how far, first how far down and how far to the right. So in this line, I notice it is falling, and then also I'm going to track its run, which will again be to the right. So I'm going to look and see my fall over my run, my fall over my run, my fall over my run. And I notice that it is going down 3 units and over 1, and down 3 units over 1 would simplify to be -3. And in line D, the line that is going up as it goes to the right, I'm going to track the rise over run because this line is going upwards. And I'm going to track from, again, the y-intercept. And the y-intercept is at +1. So I'm going to track how far up it goes and how far to the right. How far up it goes and how far to the right. And the rise here is up 1, and the movement to the right is over 3 units. Now these two slopes, I notice, have opposite signs, and I also notice that as a fraction, these are flipped upside down. This is called opposite reciprocals, and lines are perpendicular if their slopes are opposite sign and reciprocal fraction. So opposite sign and reciprocals. Now I noted over here that parallel lines is sometimes labeled like this in terms of picture format, and perpendicular lines are often denoted like this, kind of with an upside down T, if you will. Now, I have a couple practice problems. I'm going to go through 2 with you. Practice 1, now that we have talked about parallel slopes and perpendicular slopes, my first practice problem says this. On your graph, you have one line that is shown. Write an equation of a line that is parallel to this, and then graph the line on the same coordinate plane. So the key word here that they ask you for is a line parallel to your line. So first let's know what we're dealing with. The equation of this line starts at a y-intercept of -1. So in that formula y equals mx plus b, I know the y-intercept here is -1. So y equals some kind of slope that I'm going to figure out for my m, x, and then -1 being the b, the y-intercept of my function. And now let's track our slope. Notice this point over here was also given negative 4, 0. My slope of my line goes down 1 and right 4. So that slope is negative 1/4. Now, if I want a line parallel, I need to use the exact same slope, which is negative 1/4 from this line. And then I need to pick a different y-intercept because parallel lines are not supposed to touch. So I need to have a different y-intercept than negative 1. So let's pick a new y-intercept, one on this graph that is not the same intercept as negative 1. So y will have to equal negative 1/4 for x, that's my slope, it has to be the same. But now pick a new y-intercept. How about let's pick the number positive 3. If I pick positive 3 as my y-intercept, my lines will now not touch if they go in the same directions, down 1 over 4. And if I work backwards, up 1, left 4. If I connect those 3 points with a line, you'll see that these lines are indeed parallel. They go in the same direction and they never touch. Now I have a second example here for you, practice number 2. It says write the equation of the line that passes through the given point and is perpendicular to the graph of the given equation. So now in this equation here, because I'm given a point, I need to use what is called point-slope formula. Because I'm given a new point, 6, negative 2. And I also need to know the slope of my original line. My slope that was given is equal to negative 3. But if I want what was asked of me, which was perpendicular slope, I need to have the opposite sign, because we reviewed that over here, opposite sign, and my fraction needs to be flipped. So opposite sign would be a positive, and if I flip my fraction 3 over 1, this is kind of like 3 over 1, even though it doesn't say over 1, it would be over 1 if we made it a fraction. So now I want 1/3 for my perpendicular slope. Now what I'm going to do is use point-slope formula, like I said, with my new point and my new perpendicular slope. So this is going to be this equation, y minus y1. So y minus my y value equals my perpendicular slope, and then in parentheses, x minus my x coordinate, which is 6. Now minus a negative, I'm going to simplify this to be a plus. So my new point of 6, 2, I want my line to go through that new point, and I want it to have perpendicular slope. So again, I had to change the slope of my given line to its opposite reciprocal slope. If you were asked to do point-slope form of the equation here, you would be done. But it says write the equation of the line, and I don't know if they meant slope-intercept form. So in case you were asked slope-intercept form, I will show you how to transform this. So all you need to do is start by distributing your slope. So I'm going to take 1/3 times x, and I'm going to have y plus 2 is equal to 1/3 times x, and distribute your 1/3 times negative 6. 1/3 of negative 6 is negative 2. Now, if I solve for y by subtracting 2 to this side, I will have my slope-intercept form, which will be y equal to 1/3 x minus 4. And that is my slope-intercept form in case you were asked for slope-intercept form. Now here in this equation, I'm going to do this same idea again one more time. I'm going to find a line that is perpendicular to a slope of 1/2, and I'm going to have my equation go through a new point 2, 7. So the slope that I'm given was 1/2. The perpendicular slope would be the opposite fraction, so 2 over 1 or 2, and it needs to be opposite sign, which will be negative 2. Now I need to use point-slope form because I need to use the point 2, 7. So y minus my y value of 7 is equal to my slope of negative 2, and then in parentheses, x minus my x value of 2. If you were asked for point slope form, you would be done here at this step. But if you were asked to transform your point slope form into slope-intercept form, this is what you would do. You would distribute your -2 to your x and distribute your -2 to your -2. So we'd have y minus 7 is now equal to -2x plus 4. And if I solve for y by adding 7 to the other side, I will now have my slope-intercept form, which would be y is equal to -2x plus 11. And this formula would be my slope-intercept form.